I'm going to write that formula. The binomial probability formula, it's C n take x, p to the power x, q to the power n minus x. That is the probability of x. Here on this, in order one confuse, I use small p, small p. So like this, this question, n it's 15. If we're looking for p of 13, then plug into the formula. So it's C 15 take 13x. P is 1/5 to the power x. 13 question correct. Probability each question correct is 1/5. There's 4 is wrong. You don't answer correct. Probability is 4/5. How many not correct? 15 minus 13, n minus x. So it's 15 minus 13. So this it's this we call combination. This one, this combination is n factorial over x factorial times n minus x factorial. P to the power x, q to the power n minus x. So n is 15 factorial over x is 13 factorial. 15 minus 13 is 2 factorial, tying together, times 1 to the power 13, it's 1. 1 times 1 times 1, 13 times. So it's 1. Then 5 to the power 13 times 15 minus 13 is 2. 4 squared, 16. 5 squared. Then figure out this one. So 15 factorial is 15 times 14 times 13. I put 13 factorial means 13 times 12. Just one more step. Do 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Over 13 factorial. 13 factorial is 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Times 2 factorial is 2 times 1. Then times 5 bases tying together. Exponent add together. 13 add 2, it's 15. Then 1 times 16 is 16. Then you cancel. Cancel, 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 cancel. Common factor cancel until here. So remain 15 times 14 times 16. And those cancel, remain this 2 times 5 to the power 15. Then cancel. Cancel 2, get 7. So you will get it's 5 to the power 15. 15 times 7 times 16. Get this one. That's the first one. That one. After reduces, you got 15 times 7 times 16 over 5 to the power 17. That's the first one. The first one. The second term, second one, is p to the power p of probability of x equal 14. Make clear. X equal 14. X equal 14. The formula, write down the formula again, which is C n take x times p to the power x q to the power n minus x. And what is Cn take x is n factorial over x factorial n minus x factorial. P to the power x, q to the power n minus x. So use this formula. So P of x equal 14 is equal to C. Now this question, n is 15, take 14. P is 1/5 to the power x, x is 14. Q is 4 over 5 to the power 15 minus 14 is 1. Then what is 15 take 14 is this formula. So it's 15 factorial over 14 factorial, then n minus x. 15 minus 14 is 1 factorial, times 1 to the power 14 is 1. 5 to the power 14 is 5 to the power 14 times 4 over 5. 5 is 5 to the power 1. So then equal to, what is 15 factorial? It's 15 times 14 times times 13 times 12 times 11. Keep going on until times by 3 times by 2 times by 1. So you can just write down 14 factorial, because 14 factorial is 14 times 13 times 12 until 3 to 1. Over 14 factorial times 1 factorial is 1. Then times by 1 times 4 is 4. Denominator same base 5. Numerator 14 add 1, 15. Then equal 14 factorial cancel. So you got 15 times 4 is 60. And 1 times 5 to the power 15. So that's the second one. So it's we got the second one, 15 times 4 over the denominator, 5 to the power 15. Then third one, the third one is probability of x equal 15. So write down the formula again. Formula is Cn take x, p to the power x, q to the power n minus x. And what is Cn take x? It's n factorial, x factorial, n minus x factorial, p to the power x, q to the power n minus x. So this question is probability when x equal 15. So will be C, n is 15, take 15, p to the power, p its probability is 1/5. 1 over 5 to the power x is 15. Q 4 out of 5 probability is 15 minus 15 is 0. And Q, then what is 15 out of 15, which is this one, n factorial. What is n factorial? It's 15 factorial. Then x factorial is 15 factorial. Then n minus x, 15 minus 15 is 0 factorial. P is 1/5 to the power x is 15. And then this any number to the power 0. Actually, you can calculate this right now. So then 1 to the power 15, it's 1. 1 times 1 times 1, 15 times. 5 to the power 15 times any number to the power 0 equal 1. Then equal to 15 factorial, 15 factorial. 15 factorial is 15 times 14 times 13 until 3 to 1 timed together. And this is the same. So same, so cancel. Divided equal 1. 0 factorial is 1. So this is 1. 0 factorial equal 1. Any number 0 factorial we define equal 1. Define equal 1. So this is 1 times this. So it's going to be 1 over. Those are 1 time together. Denominator is 5 over 15. So the 3 probability you add together, the first one is 15 times 7 times 16 over 5 over 15. Second one is 15 times 4 over 5 over to the power 15. The last one is 1 over 5 to the power 15. So since the same denominator, 5 to the power 15, so numerator time together, you add together is 1741. Then use calculator to divide. Use calculator to divide it. You will get a very, very small number. In scientific notation, it's 5.7 rounded times 10 to the power negative 8. Very, very small number. This number is equal to 0.0123456757. You move this decimal point to the left 1, 2, 3, 4, 5, 6, 7, 8 positions over here because 8. So you left 8 position to the left. So this number, this is equal. In decimal, this in scientific notation, this put in decimal, you can see is a very, very small number, extreme small. This is an extremely small probability. Number 7. Then question 8. If 4% of calculator are defective, find the mean, variance, and the standard deviation of a lot of 500 calculators. So n equal 500. N equal 500. Defective. For this case, success is a calculator is defective. So probability of defective is 4%. Put it in decimal is 0.04. And probability of failure, Q equal 1 minus P. 1 minus 0.04 is 0.96. So also binomial, two of it. Binomial distribution. Binomial distribution, the mean, here looking for mean. Mean formula is mu equal n times p. Variance is sigma squared equal npq. So use the two formulas. N is 500. P is 0.04. Time together is 20. So average 20 calculators defective. Among 500 calculators, have 20 calculators. Average is 20 calculators defective. And the variance is NPQ. N is 500. P is 0.04. Q is 0.96. And time together, variance is 19.2. Then take square root. Get standard deviation. 4.382 standard deviation. So binomial distribution, you figure out the mean. Mean formula. First of all, you have to determine it is a binomial, has two probability, two. One is a success, one is a failure. Two case. That's what we call binomial probability. The next one, we call number 9. Number 9, we call multinomial distribution. Multinomial distribution. we are going to use this formula, multinomial distribution, this one, multinomial distribution. You also can find out on your notes, at the end has this kind of question. Yeah, page 7. Multinomial distribution on page 7. So far you already learned binomial distribution is a two case, either success or failure. Now multinomial distribution is more than two, like here. Multinomial distribution in your book is section 5.3. The binomial distribution described an experiment with two outcomes for each trial. Two outcomes, either success or failure. If there are more than two outcomes of each trial, the multinomial distribution must be used. That's question 9. We are going to as examples. The formula for the multinomial distribution is P of x equal to n factorial over x1 factorial times x2 factorial times x3 factorial, and etc. until xk factorial. If here has k outcomes, total k outcomes, times p probability for first outcome, p1 to x1, p2 to x2, until pk to xk. Now remember to put parentheses around the denominator when using the calculator. Yeah, you need parentheses. I'll show you that later. So let's see the question. Number 9. We will use this formula. Number 9. M and the M's are produced and distributed in the following proportion: 12% brown, 13% red, 15% yellow, 16% green, 21% orange, and 23% blue. In a random sample of 12 M and M's, there's 12 and M's. What is the probability of having 2 of each color? So here has how many colors? 1, 2, 3, 4, 5, and 6. 6 kind color. Then want to get 2 of each color. N is 12. N is 12. And x1 is equal to 2 brown, each color 2 of it. X1 is 2, x2 also 2, x3 2, x4 equal to, x5 equal to, x6 equal to in the formula. So in this formula, n put in 12. x1 is 2 factorial times 2 factorial times 2 factorial. So here n is 12, so 12 factorial over 2 factorial times 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 2 factorial. Then p1 to the power x1. p1 is 12%, put it in decimal, 0.12 to the power 2. P2, red, 0.13 to the power 2. P3, 0.15, probability, the third one, yellow, probability is 0.15 to the power how many? 2 of it. And the fourth one is green. Probability is 0.16 to the power 2 of it. Then fifth one, probability, orange, probability is 0.21 and to the power 2. The sixth one is probability 23%, is 0.23 to the power 2. Then figure out 12% factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And then the rest copy done. Then cancel. Those 8 is 2 times 2 times 2, cancel 8. 2 times 2 times 2 is 8, with 8 cancel. And 4 is 2 times 2, so this 2 is 4, with 4 cancel, and this 2 times 2 cancel. And then you use calculator to figure out this, the remaining, times together, and you got 0.3324. Probability also very small, is you move decimal point to the right 2 positions, get 0.24%. It is unlikely to get 2 of each color in a sample of 12. It's only 0.24% probability. Then question 10. Question 10 we call Poisson distribution. Poisson distribution. And we are going to use the formula. It's a Poisson distribution formula. P of x semicolon lambda equal to e to the power negative lambda to the power x over x factorial, where x equal to 0, 1, 2, and etc. Lambda is n times p. It's the same formula as the mean for binomial distribution. N times p is the mean of binomial distribution. Mean formula is the same formula. Now, what is the Poisson distribution? Poisson distribution is also a discrete probability distribution. Discrete is a binomial. It is a binomial distribution. When the mean is less than 5, we use Poisson distribution. Let's read this question. Question 10. A recent study showed a certain area has an average of 1 robbery per 30,000 people. In a city of 90,000 people, find the probability of the following. Use the Poisson distribution. So here A, B, C, D. 0 robbery, 1 robbery, 2 robberies, 3 or more robberies. What is the time we use Poisson distribution? When n times p, which is a mean. Mean for Poisson distribution, we don't put the mu, we put lambda. It's the same formula as binomial distribution. Mean is n times p. This question, n is 30,000 people, 30,000 times probability p. P is 1 out of 30 people. Probability, the average of 1 robbery per 1,000 people. the probability have a robbery is 1 out of 30,000 people, and have a 90,000 people. So you times 90,000 people, you got 3. So it's 3 robberies in this city. Average 3 robberies in the city of 90,000 people. Because 1 robbery per 30,000 people. Now is 90,000 people. So tying together, you got 3 robberies. If this mean is less than 5, we use Poisson distribution. We don't use binomial distribution, because when using that binomial distribution is impossible, because this n is 90,000, n equal 90,000, you won't be able to use calculator, use the table, because table doesn't have such big numbers on the table. For binomial distribution table, you cannot find out the probabilities. But we use the Poisson distribution, use Poisson distribution formula. So in the Poisson distribution, this mean we don't use mu, we use lambda represent. Lambda equals 3 here. And this one, this is the Poisson distribution formula. E to the power negative lambda times lambda to the power x over x factorial. So we're looking for probability when x equals 0, lambda equals 3. Plug in formula. X is 0, plug in 0 factorial. E to the power negative lambda is an e to the power negative 3 times lambda is 3 to the power 0. And 0 factorial equal 1. 3 to the power 0 equal 1. So that's tying together, divided by 1 is e to the power negative 3. And use calculator, figure out e to the power negative 3. Now, let's see, where is e to the power negative 3? We are looking for e. Where is the e key? And which is this one? E to the power x. So we press, is the blue one. So it's the second this. Then you will get e to the power sine negative 3. This one is sine, negative 3. Then enter. So then you will get rounded. Normally it's 4 digits. 4 digits. Yeah. Then second one, 1 robbery. So x equal 1. Lambda is 3. So will be x formula. This formula, x use 1, plug in 1 factorial. E to the power lambda negative 3. Lambda is 3 to the power x. X is 1. So you got e 1 factorial is 1. So it's 3 times e to the power negative 3, which is this times by 3. This one times by 3. And you got this one. And D and C, 2 robberies. So it's P, x is 2, lambda is 3, equals x factorial, 2 factorial, e to the power negative lambda, negative 3, times lambda, 3 to the power, lambda to the power x, 3 to the power 2. So 2 factorial is 2 times 1, so it's 2. 9 squared is 9 times, 3 squared is 3 times 3, it's 9 times e to the power negative 3. And 9 divided by 2. So you can do this number times by 9 and divided by 2. You got this number. And the D, it's 3 or more robberies. 3 or more robberies. You're looking for probability of x 3 or more than 3. So it's x greater than or equals 3, comma, lambda equals 3. Lambda is 3. So it's the same as probability of total is 1 minus the previous one, less than 3, which is x equal 1 or 2 or 3. X equals 0 or 1 or 2, not 3, not including 3. So it's a 1 minus probability of x less than or equal 2. So the total is 1 minus probability when x is 0, probability of x equal 1, probability when x equal 2, and then you will get probability more than or equal 3. So then 1 minus total probability when x is 0, lambda is 3. That's from A. X is 0 is 0.0498. Then B, x equal 1. X equal 1 is 0.1494. Then x equals 3 is 0.2240. So it's ABC. Those three probability add together, subtract from total 1, 100%, total 1. So 1 minus this, add together. So you got more than or equal 3 or more than 3, probability is 0.5768. So that's question 10. Then next page, page 6 is your formula. Then next page is a notes. It's a learning materials notes. Multinomial distribution. Here has a example. The formula is like this. Here has an example. Use this formula. It's more than 2. Binomial is 2 outcomes for each trial. And the multinomial is more than 2. So like example 525. This is come from textbook. In a large city, 50% of the people choose a movie, 30% choose dinner and a play, and 20% choose shopping as a lecture activity. 3 of it. So you can add together 50, add 30, add 20%, total 100%. So now it's more than 2 now. So we have to use this. It's we call multinomial distribution. So if a sample of 5 people, so n equal 5, this n use 5 plug in. N use 5 plug in. N equal 5. Is randomly selected. Find the probability that 3 are planning to go to movie. That's the first one. 3, x1 use 3 plug in. 3 factorial times go to movie is first one. 1 to a play. 1 to a play. So x2 is use 1 plug in, 1 factorial. The third one, and 1 to a shopping mall. The third one, choose shopping. It's 1 factorial. x3 use 1 factorial. Then 3 for movie. Each person for the movie is 50%, 0.5. There's 3 for the movie to the power 3. And for a play, probability is 0.3. And 1 for a play, so to the power 1. And for shopping mall, probability is 20%, 0.2 to the power 1 for shopping mall, so to the power 1. So plug into formula. N use 5 plug in, x1 use 3 plug in, x2 use 1 plug in, x3 use 1 plug in. And the probability is 0.5. x1 use 3, plug in. P2, 0.3, plug in. x2 use 1, plug in. P3 is 20% is 0.2 to the power x3, it's 1, and figure out. So 5 factorial, it's 5 times 4 times 3 factorial, because denominator has 3 factorial. 1 factorial is 1, 1 factorial is 1. Here has 3 factorial, cancel. Then remaining is 0.5 to the power 3 times 0.3 times 0.2. So you just tying together. So this probability 0.15. Now the number 3, 5.4, number 3. This question is the same as on the notes, number 9. Similar as the 12 choose. Have a 2 for each color. And that's where you can look at the number 9 questions. Poisson distribution. Now here has the Poisson distribution. The Poisson distribution is a discrete probability distribution. So far you learned binomial distribution, multinomial distribution. The third one here, Poisson distribution, is also a discrete binomial distribution used when n is large and p is small. And the random variable x is the number of occurrence of an event over some intervals. For example, interval means like some length or area or volume or period of the time. The Poisson distribution with lambda equal np can be used to approximate the binomial distribution when np less than 5. So when given n and p, if you tie together, that's the mean for binomial distribution. If that mean is less than 5, then use Poisson distribution to approximate the binomial distribution. So instead of using binomial distribution, use Poisson distribution, this formula to do. When n times p is very small, when n is large, p is very small, tying together if less than 5, use Poisson distribution. So Poisson distribution is a binomial distribution, but in the special case situation, use Poisson distribution, right? So, and the note, round answers to 4 decimal places. 4 decimal places. So let's see one example. If there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page, one page, has exactly 3 errors. So n equal 1. N equal 1. What is the p? So there are 200 typo errors, 200 errors out of 500 pages. So you divide it, you will get 0.4 errors per page. Per page has 0.4 errors. That is the probability. And since figure out a given page, so n equal 1. So n times p. N is 1 times 0.4, get 0.4. That's the lambda. Lambda is 0.4. That means 0.4 errors per page is average. Average is one page has 0.4 errors. And since this number is very, very small, less than 5, So use the Poisson distribution to approximate binomial distribution. So Poisson distribution is this formula. P of x is 3 errors, has exactly 3 errors, so x equals 3. And lambda is 0.4 probability. Formula e to the power lambda, e to the power net is 0.4. Lambda is 0.4 to the power x. X is 3. Then x factorial, 3 factorial. And use calculator, figure out. 3 factorial is 3 times 2 times 1 is 6. So we divide it by 6. And use calculator, figure out is 0.0072. It's very, very small. It's a move decimal point to the right 2 position is 0.72%. That's very, very small. So this one, number 9, this also Poisson distribution is similar your notes previous question 10. Similar, you can look at question 10. Have this robbery questions. It's I think it's question number 10, right? Yeah, question 10. Then next one, we call hypergeometric distribution. This is also one kind of discrete probability distribution we call hypergeometric distribution. It's one kind of discrete probability distribution. So far you have a discrete probability distribution. Have the first one is a binomial distribution, and then the second one is if more than 2 outcomes for each trial, then we use multinomial distribution. Then you have a Poisson distribution. If n times p, the mean is less than 5, you can use Poisson distribution to approximate the binomial distribution. The third one, the fourth one is a hypergeometric distribution. So this one is have this formula, hypergeometric distribution formula. The hypergeometric distribution is used when there are 2 outcomes and the sampling is done without replacement. There are 2 outcomes. The probability of selecting without replacement x items of the first type is x. The probability of selecting without replacement x items of the first type and n minus x items of the second type is where A and B are the number of items of each type. This formula. What this means, let's go one examples. The following example show you. Example, a recent study found that 2 out of every 10 houses in a neighborhood have no insurance. If 5 houses are selected from 10 houses, total 10 houses, there's 2 types. Find the probability that exactly 1 will be uninsured. So you look at this formula, the probability of selecting without replacement x items of the first type and the n minus x items of the second type, where A plus B are the number of items of each type. So here, there's 2 out of every 10 house. A plus B have 10 house. There's 2 house in the neighbor, no insurance. Out of 10 house, there's 2 house, no insurance, A equal 2. And have 10 minus 2, have A house, there's 2 outcomes. One has insurance, the others no insurance. From 10 house, 2 house, no insurance, and A house has insurance. So it's two types. A and B are the number of items of each type. A equal 2, no insurance. B equal 8, has insurance. A plus B, total is 10 house. Now, question 1 you, if 5 houses are selected from 10 house, so n equal 5. Once you find out the probability that exactly 1, so x equal 1, will be uninsured, no insurance. So from looking for probability, if you have 5 house you selected from those 10 house, what's the probability you got? 1, x equal 1. 1, no insurance.